All right. Today we are going to solve this problem, which is rotting oranges, and it is again categorized as medium level problem. You are given an m times n grid, m times n grid. It's like a 2D dimension where each cell can have one of the three values: 0, which represents empty cell; 1, which represents fresh orange; 2, which represents rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Okay, any fresh orange becomes rotten that which is 4 directionally adjacent to the rotten orange. Return the minimum number of minutes that must elapse until no cell has fresh oranges. If this is impossible, return -1. Alright, return -1. Let's understand the question first, okay? Let's understand the question first, and then we will do it, okay? What the question is asking us is, we have been given a m times n grid, okay? M times n grid, like see here, this is rotten orange. Let's take this example, rotten m times n, so row and column, okay? So suppose this is, oh my god, sorry. Okay, 2 1 1, right? 2 1 1 and 1 1 0 0 1 1, right? And 1 1 1 1 0 0 1 1. Now, what the question is asking is, in every 1 minute, in every 1 minute, what happens is, whatever whatever the whatever the item is there which is four directionally to this item, four directional, right? Is it right? Is it left? Is it bottom? Is it at the top? Four directional, to this item. In every 1 minute, it becomes rotten. So 2 represents rotten, 2 represents rotten orange, 1 represents fresh orange, and 0 represents empty. Isn't it? 0 represents empty shell. Here, these three, right? 0 represents. In every 1 minute, what is happening is this. In every 1 minute, right? The fresh oranges, which are four directionally adjacent to the rotten orange. This two is rotten orange, will become rotten. So this is rotten. To the right, it will remain same. Again, it's at the bottom. It's adjacent to the rotten, right? So it will become rotten. Fresh 0 0 1 1. This is first lap, right? First lap, isn't it? First lap. Now, in another 1 minute, this is rotten. It has got two adjacent sides, right, three adjacent sides, right, left, and bottom. There is no top. So, what will happen is, here is this rotten will make this fresh orange rotten again. 2. This will make rotten as well. 0 is empty. 0 is empty. This will remain same. This is second lapse. second lapse or second minute, isn't it? Yes. Now what will happen? It is another 1 minute, which is third lapse. In third lapse, what will happen is this rotan, there is this rotan image, sorry, this rotan orange will make this fresh orange rotan, right? Other adjacent sites are already rotan or empty. So 2 2 2 2 2 0 0 2 1, right? 0 2 1. I just fix this. This is 0. Okay. This is which lapse? This is third lapse. We have to return what? We have to return the minimum number of minutes that must elapse until no cell has fresh variant. Fresh variant. Until we have to make this whole whole grid what? Full of rotan or empty cell, right? Empty cell. So we have still one more fresh orange left, and it can be rotan because it's adjacent to this rotan orange, right? To this rotan orange. So in another 1 minute, what will happen is 2 2 2 2 2 0 0 2. This rotan and has adjacent. This rotan is adjacent to the right, right? Adjacent this fresh orange here. This fresh orange is adjacent to this, adjacent exactly right to this rotan orange. So this should be rotan again. So in this way, in the fourth lapse, what happened in the fourth lapse, fourth period, or in 4 minutes, 4 minutes, what happened? The whole this whole in the 4 minutes of time, this or 4 minutes of time, this whole grid become rotan or empty. So we have to return 4. That's why we have to return 4. Okay, we have to return 4 from here. Now adjacent sides. There are 4 adjacent sides to a rotan orange, right? To a rotan orange, isn't it? There are 4 adjacent sides. One is right, 4 adjacent side, right? One is adjacent side would be left. Another would be right. Another would be top, and another would be bottom. Another would be bottom. If we see in this in a given scenario, right? If in a given scenario, right, in x comma y case, the left will be right. The left here, left would be x plus 1. Sorry, x left would be what? X left, right? Left would be x minus 1 comma y, isn't it? X minus 1 comma y. Right would be x plus 1 comma y, and top would be x comma top. If it is x comma 2, right? If it is uh, x comma y, right? X comma y. In this scenario, it would be top would be this part. If we have to go in a horizontal axis it would be x and x, and if you have to go in a vertical space it would be y, right? So if it is in x comma y, right, if you x comma y, then if we need to find the top, then it would be y plus 1, isn't it? Y plus 1, so y plus 1, right, y plus 1, and bottom would be obviously the y minus 1. Okay, y minus 1. So in every minute, so here in every minute, right, if we have to check, right, in every minute, sorry, if in every minute, if the if the rotten image is equals to 1, right, equals to 1, then what you have to do is we have to, in every 1 minute, mark 2, mark 2, okay, mark 2, mark 2 for, in every minute, if any left, right, or top or bottom, these adjacent parts of 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 rotten orange, if that is what I'm trying to say is, if, right, in every minute, if right, left, top, bottom, right, bottom is equals to 1, then mark 2, mark is 2, mark is 2, in every 1 minute, in every 1 minute, for what, for the adjacent parts of this rotten image, right, of this rotten, this is the rotten, 2 is the rotten, 2 is the rotten, so bottom and right should be marked as 2. Got it? Yeah. Oh my god, I forgot to record. Okay, I'll repeat that again. Eraser. What I'll do is I'll just I'll just revise that once more. Okay, what I was saying was, in this example of an array which is very simple, which has got only one rotten orange, and it took like 4 minutes of interval to 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 get an array full of rotten oranges and empty cell. What we have got, what if we have multiple rotten oranges inside an array? What would happen? So let's take black. So suppose we have in this array, big array, which has multiple rotten oranges, 1 0 2 1, 0 1 1 1, right, 1 1 1 2. We have got multiple rotten oranges here. So according to the question, what we have to do is, the adjacent parts of the rotten oranges, which are, if there is any fresh oranges that is adjacent directly to the rotten oranges, should be rotten. We have to mark this as 2. This is adjacent 2 2, and this is top left 2 2, meaning, okay, so what will happen is, in the very first minute, In the very first minute, this will be rotten. This fresh orange will be rotten. In the same minute, this will be rotten, and this is adjacent, right? This will be rotten. And in the first minute, this will be rotten. This will be rotten. Okay, this is how the algorithm should work. In the very first minute, if there are any multiple rotten oranges, then the adjacent parts, the which has fresh oranges should be rotten. In the second minute, what will happen? It does not have rotten. There are fresh oranges, right? We also need to know there are fresh rotten oranges. So this is already rotten. Here we have got fresh orange, right? Here we have got fresh orange. So what will happen? This will be rotten. This will be rotten. Here this will be rotten. This will be rotten. In the second minute. And in the last third minute, we have got one last fresh orange left. This will be rotten. So we have to return 3, right? We have to return 3. Okay. Okay. Now, how will I solve this? How will I solve it? In order to solve this, we will be using breadth first search approach. Okay, BFS approach. So I'll be using Q. I'll be using Q. Just we have to return. We know that, right? We don't have to write this. We have to return 3. Okay, we will be using breadth first search approach. Breadth first search approach. So first, I will be storing. Okay, I will be storing all the rotten parts. All the rotten. This one, rotten. This one, and this one inside the our queue. Okay, inside our queue. Let's also let's also uh, mm, 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 what do you say? Let's put 1 2 2 3. This is row column. Okay, let's put row column number 1 2. Not blue. I'll put red, green maybe, orange maybe. No, green maybe. Right, 0 1 2 3. Right, 0 1 2 3. So at what position our rotten oranges are? At what position? First is 0 comma 0, right? 0 comma 0. Second is at part, this one, 1 1 comma 2, x comma y, 1 comma 2, 1 comma 1 comma 2, right? And third is here. So this one is 3 3 comma 3, 3 comma 3, 3 comma 3. So we know that now we know where our rotten oranges, where our rotten orange is inside this big array, right? Inside this big array. Now what we will do is basically, all right, what we'll do here is we have got the position of our rotten oranges. Position of our rotten oranges. Now, what we are going to do here is then okay, what we are going to do here is, now we know this part, this position is rotten orange, this position. Now what we'll do is, in every 1 minute, okay, in every 1 minute, in every 1 minute, first I'll check the I'll check for this one. Okay, I'll check for this one first. I'll check for this one 0 comma 0. I'll check the I'll check its adjacent parts. I'll check its adjacent parts, right? Top, there is no top, there is no left. I'll check right and bottom. I'll check right and bottom. if if they are right, I'll check I'll check this part, right? I'll check this part here, this part. If right and left or bottom is equals to 1, I'll mark them 1. I will mark them as 2. If they are 1, I'll mark them as 2 and add their position and add their position, this position and this position into the queue. Add their position into the queue. Okay, add their position into the queue, and after marking that, add their position into queue, right? Add their position into queue. So what we have to do here is we have to add their position. What is their position? For example, 0 comma 1, right? 0 comma 1 and 1 comma 0, 1 comma 0. And also I will remove the what? Remove the original this rotten orange position. Remove from the queue, okay, from the queue. I need eraser. I will remove this. I'll remove this. I will remove that part. Again, I'll check for this part, this one. 1 comma 2, 1 comma 2, this one. I'll check top empty, left empty, right and bottom are 1 and 1. So I'll mark them as 2 and make them total. And then add their position into Q. Add their position into Q. Now let's add let's add this one first. 1 comma 3, 1 comma 3, right, 1 comma 3 and what, 2 comma 2, 2 comma 2, 2 comma 2 comma 2, and I will also remove this part from the queue, now left is this 3 comma 3, which I'll check the top. We have got top and left, I'll make them rotten and I'll add their position, which is 2 comma 3, 2 comma 3 and 3 comma 2, 2 comma 3 and 3 comma 2, and I will remove this. Okay, I will remove that, and what I will do is now this da, 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 da. Oh shit, da, da. So our new queue is looks like this. Okay, first what I'll do, once again, uh yeah, yeah. Oh my god. Let's pen. All right, it doesn't matter. So original queue. This is after minute, right? After 1 minute, right? First queue was what? Queue was 0 comma 0, uh, 0 comma 0, 0 comma 0, and oh, 1 comma 2, 1 comma 2, and the 3 comma 3, right? 3 comma 3. This is after 1 minute, right? After 1 minute. After 1 minute. Okay, now what will happen? Now what will happen? Okay, I'll make this a little bit up. Now what will happen is, now we have got in 1 minute, we have got another a queue, another list, another array of rotten oranges, another array of rotten oranges, which is at this position, right? In 1 minute, in the first minute, in the first minute, in another, in the first minute, right? In the very first minute, in the very first minute, right? First minute has gone. Now, now, now what we will do is we'll check for these these positions. These positions we'll check their adjacent parts. We'll check their adjacent parts. Left, we'll check their adjacent parts. I'll just adjacent parts. This right, left, top, bottom. Right. Let's start from here. 0 comma 1. Okay, 0 comma 1. I will make another queue just to, no, not here, not here, not here, not here. I'll make it here. Oh yeah, I will make it here. Okay, I will make it here. Okay, I will check for 0 comma 1. Where is it? 0 comma 1. This one. Does it have? Does it have? No, it does not have. Okay. Sorry. So what I was saying was, we were checking which position, 0 comma 1, right? 0 comma 1, this position, right? This position we were checking the adjacent parts. Left is already written. It's empty, it's empty. So there is no any adjacent parts which we need to make it, which we have to make it, make the rotten, right? So it will pop out of the queue. Okay, it will be popped out of the queue. Now we'll check for 1 comma 0. 1 comma 0, same thing, right? Top is already written, it's empty, it's empty. It will also be popped out of the queue. 1 comma 3, 1 comma 3, we'll check for this part. Okay, we'll check the adjacent parts of this one. 1 comma the top. Okay, the top we need to make it rotten, right? Because it's 1, we'll need to make it 2. It's already rotten. It's already rotten. It's already rotten. It's already rotten. So only top, right? This part, only top part. So what we'll do? We'll add this position into the queue. What is the position? 0 comma 3. We'll add here 0 comma 3. 0 comma 3, and we will pop this out of the stack. Now 2 comma 2, 2 comma 2, this part, sorry, this part, right? This part, the top we'll check for adjacent parts. The top is already written, right is already written, left is 1, which is fresh. We have to make it rotten. So we'll make it rotten and add this position 2 comma 1, 2 comma 1, 2 comma 1. Okay, 2 comma 1, and we'll pop this out of the scan. 2 comma 2, right? Already bottom is already rotten. Okay, bottom is also already rotten in the I think in the first minute, right? In the first minute here. Now 2 comma 3, 2 comma 3. Does it 2 comma 3? Does it have any adjacent paths need to be make it rotten? It's already rotten. It's already rotten. It's already rotten. No, it will pop out of this time. 3 comma 2, 3 comma 3 comma 2. This part. It has got top top already rotten. Left needs to be make rotten. It's fresh. Right is already written, there is no bottom, so this position needs to be, we need to make it rotten, and add this position into the queue, which is 3 comma 1, 3 comma 1, 3 comma 1, 3 comma 1, and it will be popped out of the stack, popped out of the stack. All right, popped out of the stack, right? Popped out of the stack. Another minute has passed. 2 minutes, right? 2 minutes. Okay, 2 minutes. Now, now, now we have got three positions of the rotor orange inside our queue. Okay, inside our queue, what you have to do is we have to check their adjacent paths, right? Okay, let's check their adjacent path. 0 comma 3, 0 comma 3, 0 comma 3. There is no top, there is no right, or left is empty, already rotten. So it will pop out of the stack, pop out of the stack. 2 comma 1, 2 comma 1, 2 comma 1, 2 comma 1. This part, top is empty, left is empty, right is already rotten, bottom it will pop out of the stack. 3 comma 1, 3 comma 1. Okay, the left we need to make it rotten, top is already, bottom there is no bottom, right is already, so we have to add this position inside, which is 3 comma 0, 3 comma 0, sorry, 3 comma 0, right? And then there is everything, and it will be popped out, the queue will be empty, so we have got new queue in 3 minutes, 3 minutes of time, 3 minutes of time. Okay, in 3 minutes of time. Now we have got one more queue here. Now we have to check it. 3 comma 0, top, there is no left, top is empty, right is already rotten, there is no bottom, so it will pop out of the stack and queue becomes empty, and queue becomes empty here. Okay, now as I've already said, what will happen is now we'll check for 3 comma 0, and the queue is empty, right? Queue we have queue is empty because the left is there is no left, top is already empty, right is already rotten, and bottom is there is no bottom. Okay, so queue becomes empty once. Okay, once 1 second, I'll make it lesser. What I'll do is I hope everything is selected. da, 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 da. Okay, so sorry. Okay, now what we'll do is once the queue becomes empty, okay, I need pen. Once the queue becomes empty, okay, once this queue has become empty, what happens is if we'll go through this whole array, okay, we'll go through this array after this, okay. Oh my God, sorry. Once once queue is empty, right? Once queue is empty, what happens is if we'll go through this whole array, if any location, if any location we found is there one, then it means what it means is that it was impossible to make it rotten, so we return -1, we return -1, Okay, minus 1, or else we return the minutes, or else we return um, we return minus 1, else return what? Minutes. Else return minutes. Else return minutes. I have recorded. Yes. Okay, now let's convert this into code. Okay, let's convert this into code. Okay, var we have this 2D array of number. Okay, first let me light the logic. First we add all the rotten oranges into queue, right? We will add all the rotten oranges. Why I need the queue? Because in order to save the indexes of all the rotten oranges, and after a minute I need to record another, right? I need to record the indexes of another rotten images if there is available, right? That is why, okay, that is why we need queue. Now next, and then what I'll do, I will mark adjacent nodes is rotten and push into queue, push into queue, right? Push into queue. Continue till queue is not empty. Okay, continue till, and finally run over each element in that array in check if any fresh oranges are remaining, right? This is what I have explained remaining in the logic part, right? Same thing. First, let's initialize, let yum equals to greet dot length. This is the row, okay, row, right? Greet dot length. Let yum, it will be greet of 0 comma length, should be column, and we need queue, right? We need queue, which is array based, and now we need to add all the rotten oranges inside this queue. Okay, okay, let's add all the rotten oranges into the queue. For let I equals to 0, I is lesser than yum, we look through first yum, all the rows, and I plus plus, and we'll go into the columns. Let z equals to 0, j is lesser than yum, j plus plus, right? J plus plus, and okay, from this loop, now we have to push first. How will I push the rotten oranges into queue is if, right, grid of if grid of if grid of how how, right, if grid of I or j, right? I, that is 0 comma 0. For like if I equals 0, that would be grid of 0 comma 0, 0 comma 0 is equals to 2, then that is roten, right? Then that is roten. That is roten, right? So q, we have q have method push, right? Q have method push, and it will take, we have to put the what, the index, right? In the index, yeah, index I comma j, isn't it? I comma j, yeah, I comma j. Now comes the interesting part. We have pushed the rotten oranges, all the rotten oranges into the queue. Now what you have to do is we have to mark adjacent nodes which 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 are fresh, that are adjacent to this rotten oranges into the queue, isn't it? You have to find it. Very interesting part. So, so first thing first, what you have to do is we need to have, obviously the corner case would be if there is only q, if there is only oranges, rotten oranges. What you have to do is, first thing first is we have to check the adjacent nodes of the rotten oranges. If there are rotten oranges inside q, that means q dot length. If there is q dot length, then then what you have to do is, if there are rotten oranges, then we have to find the adjacent nodes, right? Adjacent, we need to know the adjacent nodes, right? But before that, I need to, if there are multiple rotten oranges, then I need to get the first one, right? So first one, or I need to, yeah, first one, right? Start from the first one. Let's get the current. Which, how do I get the current? And the q has method shift. Q has method shift, right? Q has method shift. Shift, which will give us the value of the current, or the first one, right? First in, first out, right? The first one, the position, isn't it? Position. We What we have got here is the index of the current rotten image, which is like 0 comma 0, right? 0 comma 0, right? Let's take this in this format, x comma y, walk x comma y. Now we need to get the adjacent nodes, like left, top, right, bottom, like that. So we have to check that. We have to check if there is any phrase. For example, let's check for left, right? Let's check for if grid of x left, right? Left, x means that 0, which will be -1, and -1, comma, y, is equals to 1, then what you have to do is we have to mark it 2, right? 2. So how do you do? Grid of, right? I think I made a mistake here. One second. Grid of x minus y comma y, right? Y equals 2. We have to make it 2, right? And also we have to push it, right? q dot push what? X minus 1 comma y, x comma 1 minus 1, and then, yeah, and then we have to check for right. I made a mistake here. The grid of, I need to check the left, right? That and that. if this position X, meaning what I'm to say is, if this is the one, if suppose here, right, is the left, right, if X minus 1 will be this, and if this one, this position is 1, right, if this position is 1, right, if this position is 1, so if this position is 1, then uh, then here also grid of, right, grid of that position we make it 2. Now it looks good. 2, right, we made the value for this position is 2, meaning we made this as rotor, right? Yes, rotor. And then we push the indices x comma y to the q. Yeah, like this. Yeah, true, true, true. Yeah, indexes. Okay, now looks good. Okay, now we'll do the similar thing for our right, which would be +1, and for our d plus right, for our top, mm, for our top b plus 1 for our top, right, and we'll do the same for our bottom. Okay, bottom d -1. Okay, -1, let's print this. Yeah, -1. If they are 1, if they are 1, then make it 2 and push it into q. Right. Okay, now we have done that. So what will happen? It will get the current, it will get the current index, current position, current position value from the queue, and it will do all the, it will check for all the adjacent nodes. If they are 1, then it will convert them into roton and push them into queue. It will run, right, it will run till the queue, till um, there is what rotten oranges inside queue, and once the queue is empty, or once the queue is empty, or now we'll check if I equals to 0, I is lesser than I plus plus, or let I equals to 0, I is lesser than I plus plus, sorry, j, right, j, and what we'll do here is we'll go through all the elements, we'll run over each element and check if grid of I comma j is equals to 1, then it means that we cannot make that fresh orange as rotten, so we need to return -1, right? Now the hard part is how to we have to return minutes, right? We have to return the minimum number of minutes. We have to return the minimum number of minutes. Now how to find out that count, the cycle it take, right? It took us to basically convert all the fresh oranges into rotten, or how long, what is the number of minutes it took us to determine that all the all the whole array does not contain any fresh oranges. How to find out? It is the most difficult part. Okay, now how can we do that is we can initialize minutes. Let minutes equals to 0. So 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 the first thing is can we increase the minutes for every value, right? Can we do that? No, that would be silly. That would be silly. That would be silly. That would be silly. I've found one corner case here. The corner case is this. So this can go negatively, right? This can go negatively -1, or it can go above the length of the row, right? It can go above the length of the row, isn't it? So right, it can go above the length of the row, or it can go negative y-axis. So in order to fix that, we have to do if x is only greater than 0, then do that, right? Sorry. Dot. And it cannot go, x cannot be what? If only x is lesser than yum length of the row, -1, then do that, right? Then do that, otherwise don't do that. Same thing if if y is less than yum -1, then do that. Shift, do that. Same thing, if y is greater than 0, do that, else don't do that. Shift, right? Yeah, I think this will work. I mean, we have to check this is the condition. This from this code, right? And let's check if we are getting what we want or not by doing console.log grid, right? Console.log grid over here. Oh my god. Oh, sorry. Should put this, right? Okay. 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 Initially, our let's make it a little bit expected for. Okay. Uh, let's make it a little bit beautiful. Okay. So that 0, 1, 2, and all right. I think this will make it beautiful. Yes. Yeah. So this was our initial whole given array. It first, in the first, right? First, what it did, it it uh, it pushed it pushed this two into the queue, this rotten orange into the queue, and it in the second in the and then it looked for its adjacent part, one and one. It converted those into rotten, and these fresh oranges, it converted these fresh oranges into rotten, right? Rotten, rotten, right? Rotten. And then what it did now, now it has to check for this and then push those position into the queue, right? Now it is checking for checking for this and this one. And then okay, 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 it's not converted. Hmm. Okay, okay, it's it written 4, right? Now it converted this phrase, the adjacent part to this one is this. So it converted this phrase into rotan, so it is 2. Hmm, Now and then here, one by one, right? It's converting one by one, and finally it has converted whole array into whole array full of rotten oranges and empty cells. Isn't it beautiful, right? Mm, Looks like algorithm is working fine because it converted all the fresh oranges into rotten, and meaning that this cell has no any rotten oranges. Mm, mm. But the thing is, how do I calculate the count? Minutes. It took us, right? It took us to basically make the cell without fresh oranges. Hmm. So how we are going to find out the count, the minutes it took us to make the hmm. Okay. Uh, there are multiple ways to to find out the counts, but what at the moment it's coming in my mind is uh, the thing is what we are doing here is what we are doing here is in 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 first we are basically pushing the rotten rotten oranges only, right? Rotten oranges only, and then we are finding out the adjacent nodes that are need to be made rodon, which are very fresh, right? Which we have to convert the fresh oranges into rotten. For that, for that it should be 1 minute, isn't it? For that, uh, in every minute, or any fresh oranges that are directly adjacent nodes that are directly adjacent to the rotten oranges needs to be rotten, right? In every 1 minute. That means for this 1 minute has passed, isn't it? For this 1 minute has passed, and after uh, once once we find out that all the adjacent nodes, once we push them into the queue, that means 1 minute has passed. 1 minute has passed, and we have to again check for those for check for the what uh, check for the adjacent nodes of those rotten images which are in the queue again, and again we have to mark them, find out the find out the adjacent nodes which has fresh oranges. We have to convert those into rotten image and push them into queue, push the position of those rotten oranges into queue, right? rotten oranges into queue, right? Rotten oranges into queue. For that, it should be every 1 minute. So what actually coming on my mind at the moment is for every iteration, meaning we are converting we are converting fresh oranges into rotten and pushing them into queue, that is 1 minute. So what it is coming into my mind is, in the first place, whenever we are pushing the all the rotten oranges into queue, what we can do is we can also pass minutes into the queue, and in each rotation we keep incrementing, right? We keep incrementing. In each iteration, we keep incrementing, right? We keep incrementing. What I mean by that is, we pass we pass in the first iteration, we pass 0 minutes, right? We pass minutes as zero or count as zero, right? And in the first iteration, or in the first minute, what we do is we increment the count, we increment the minutes by one in each iteration. Okay, in each iteration. I think that would be the best way to solve this problem. Okay, that would be the first. What I mean by that is, in the first, whenever we are pushing here, we pass minutes as zero, initial zero, initially into the queue. And whenever we are here, we get minutes in this while we are shifting the current from the queue, right? And whenever we are finding out that, or whenever we are converting the fresh oranges into rotten and pushing the position of that rotten orange into the queue, we increment the minute by one. Increment the image by, sorry, minutes by one, right? Minutes by one. Uh, what I'll do, Control D, I think no, Control B, Control B, and also here, Control B, in every iteration, right? Every iteration looks good. Now, while we are adding minutes for each iteration and keep incrementing, we have to of keep track of the minutes that is maximum at certain point, right? At certain point while iterating, right? So in order to do that, what we'll do is minutes equals to, this will be the final minutes, I mean the output, the return, what we have to return, right? That is math dot max. It will be minute comma minutes. Math dot max will compare with. All right, let's final check the answer. So first we have converted. First we have pushed the rotten orange into queue, and then we have find out the adjacent nodes that are fresh, and converted them into rotten, and then push them again into the queue. And then we are checking all elements. If there are any fresh oranges, then that is very hard, or that is impossible to convert them into rotten. If that is the case, we are converting them into -1. And then for minors, it was a little bit interesting, right? What we did was, initially we passed pass 0 as initial minute, right, initial count, and then as we is for each iteration, meaning for each for every minute while we were right for while we were converting the fresh oranges into rotten for for every adjacent nodes, for every adjacent nodes, and pushing their position, right, pushing the position of the rotten images into the queue. We were incrementing the minutes, and finally we find out the maximum minutes, I mean max minutes it took us to basically check or to convert the cell into full of rotten oranges. We find out the maximum count cycle and then return that. So let's check that, check the final, let's test it out. Okay, is not serialized. What is this? Where null is not valid, car 20. Okay, one second. So where did I okay. Math.max minimum minutes. Okay. Ah, you've done it. All right. Yeah, the test is successful. Talking about the time complexity. Hmm, Talking about the time complexity here, we are basically looping through m and n, so it will be O big of m times m, which is OM. O time complexity will be time TC, right? Time complexity would be big O of yum times yan, and space complexity would be, we are using Q, so same thing, yum times m, which is yan square. Finally we did solve this problem. Thank you for watching this video.